Let's hack a smart contract. Guys, we need to talk.
We need to talk.
We need to talk here. This is not one of the talks that your dad gave you when you were a kid, but a talk that I'm going to give you guys right now. And we need to talk about smart contract security. And smart contract security is a very important topic that's going on, a very important buzzword that's happening in the industry right now, because Web3 and blockchain really do need it in order to move forward. Now, right here, we have a very simple demo project here, but this is going to teach you guys how to hack a smart contract. Now, on the surface, it doesn't look too bad. There aren't any sort of crazy errors. There aren't any sort of crazy red underlines here. This contract looks pretty good by itself right now. And that's the tricky part about it right here. What we need to make sure is we develop a keen eye so that we can spot these flaws in these smart contracts and that we don't make these mistakes and we don't lose protocols a lot of money. So let's go ahead and just kind of walk this line by line here so we kind of understand what's going on in the contract and why it is improper. So right off the bat, we have a contract called "This contract is vulnerable." So if the name of the contract is "This contract is vulnerable," it might be vulnerable. We have two state variables here. We have a address public owner. We have a UN256, which is the contract balance too. We have the constructor that sets whoever deployed this contract to be the owner. So we know we have some type of authority system going on here that somebody's in charge of this contract. We have a function to fund the contract so people can send funds to this contract. And then we have a function to send the funds here. So funds can go in the contract and then funds can come out of the contract too. Now, for you gigabrains out there, you guys might be able to spot the flaw right now, but let's see if we can figure it out. So in Remix, I'm going to go ahead and deploy this contract. And let's take our address here. Let's actually take a different address and let's go ahead and fund this with, let's say 5 Ether, which is a lot, but let's go ahead and fund the contract here. Now, if we go to the owner, we can still see the owner is the DC4, which is the initial address I used to deploy the contract. And we can say if we look at the balance here, we should have 5 Ether. And if we count on all these zeros, there should be 18 zeros, so it's 5E18. Now, the issue is this function right here, if we want to withdraw the funds out of this here, we can switch to a different account. We can switch to any one of these accounts, any arbitrary account, any random Joe off the street, and we can withdraw all that money. We can copy our address from here, and we can withdraw all of that money. And we can see that now this account right here has more Ether than it did before. They essentially stole all these funds that they shouldn't have been able to. Now, how do we fix this? It's actually a pretty easy fix here. Require the message.sender is equal to the owner. Otherwise, you are not allowed to do this. Now, you might be saying to yourself, this is a really simple mistake. Probably nobody ever makes this mistake in the real world. Come on, it's so simple. It's so easy to pick up. I bet this never happens in the real world. But although the cases are a little more complex here, broken access control is a huge issue with Web3. And if we go to Solidate and we just search for access here, we can see that different contracts and different findings allow for improper access control for different live public audits. So we can see that this protocol right here had an issue with improper access control. Of course, you can read more of this on your own time here, but this is just one example of improper access control. And there's no shortage of these, right? There's a bunch of different findings here that have improper access control. Now, this is just the very tip of the iceberg. There's a bunch of different security ideas and concepts that we can go over, and they're still being found to this day. In fact, professionals in this field like to refer themselves as security researchers because they're constantly researching and finding new exploits and vulnerabilities that could happen with these smart contracts. Now, if you guys want to learn more about that or just smart contracts in general or blockchain development in general, be sure to hit that subscribe button down below. Give me a thumbs up if you guys enjoyed this video, and I'll see you guys in the next video at the Crypto Gym. Take it easy, guys.